I'm super happy to be talking today about measuring the quality of natural language generation systems. And I actually didn't quite know what to title the talk because it's quite broad in scope. And I'm going to go into more depth later, but there isn't really one theme. And the main theme that we're going to have is whether we can measure the quality of natural language generation systems and how to measure it or how to not measure it. Hence the title. Since many of you might not be super familiar with natural language generation as a research field, I want to first start by giving you a little bit of a background as to what all of the terms I'm going to use throughout this talk actually mean. So what we define as natural language generation is often this transformation of structured or textual information into natural language. That natural language needs to be fluent, understandable, and in accordance with a particular communicative goal, so that an NLG system has this communicative goal and needs to complete some NLG task. An NLG task is defined by having such goal. To be a little bit more precise and give you an example, let's have a look at one or two different NLG tasks. The first one, which is probably the most popular at the moment, is news summarization. Here, the input could be a news article of about 600 to 800 words, and the target, a 2 to 3 sentence summary that presents the main ideas. We can quickly see that there are many, many challenges of this task. Importantly, a system, an NLG system, needs to identify and select the important content from the long article and plan the summary structure in some way. So as shown on the right here, we might have this really long article, and we only want to present this overview that makes people click on the article. So that needs to be planned somehow. What do I say first? What do I say second? Then an NLG system needs to actualize this plan in natural language. And while doing so, it shouldn't hallucinate, right? It shouldn't generate any content that is not grounded in the input or that is not attributable to the input. Another NLG task is biography generation. That one's maybe a little bit more of a toy task or an artificial task, but the communicative goal here is to generate a brief description of a person grounded in descriptive attributes. Language, but rather key value attribute pairs, as shown on the left here, where you might have the info box from a Wikipedia article. The target could be a one paragraph biography that describes the person, and this task obviously also has associated challenges with it that are actually very similar to the news summarization task. Here, the system still needs to plan the biography structure, but it needs to also do so to incorporate the entirety of the input attributes rather than just the important points. It still needs to actualize this plan in natural language, and it also shouldn't hallucinate, i.e. generate ungrounded or non-attributable content. So you can see how two very, very different tasks that only have on the surface a similarity that the output is natural language actually have a lot of similar challenges. And we see this reflected in how these systems are being evaluated as well, since the evaluation in general has a lot of similarities among different NLG tasks. I'm going to structure my talk into 3 parts. In the first one, I'm going to give you a brief overview of how NLG systems are being evaluated today. Then I'm going to mainly talk about pitfalls and best practices in these evaluations. And finally, how to implement these best practices in GEM, of which we're currently releasing the second version, where GEM stands for the Generation Evaluation and Metrics Benchmark. So let's start with the first question, which I actually want to reframe a little bit in terms of the actual consumer of the evaluation. So we can ask, what should our results tell us about the model? And depending on who I am and what I want from the evaluation, I can ask different questions. So the most obvious first one is, if I am a researcher, I might want to ensure that the model performance claims that I make are confirmed through the evaluation. I could also ask the question, is what I'm currently building the currently best approach to address a particular problem? Or what are shortcomings that future researchers should work on? However, if I'm maybe in industry and I'm a product manager, I might ask a completely different set of questions. I might ask, does the model meet the quality requirements we set for this product? What is a catastrophic failure of a model and how do I prevent it? How does a model perform on real-world data that does not necessarily look like the data that a model is trained on? And how is the performance on different user personas? Maybe someone in a different country or who speaks a different language might have Similarly, to what we want to answer, there are also different aspects of generated text that we can measure. If you are familiar with the general field of NLP, you've probably heard of NLU tasks, which are typically evaluated using some kind of accuracy score or F1 score, where you simply compare the prediction to some ground truth number, and if it matches, you get a point. If it doesn't, you don't. Unfortunately, this doesn't exist for natural language generation, which really makes the whole evaluation process a lot more complicated. Since the output space is so incredibly large, I mean, we can pick from all of the language, all of the vocabulary at every point in time and choose over and over different words. The space is much larger, and something that is phrased completely differently might still be correct. So what we need to do instead is we need to characterize the output somehow. And we can do this in terms of very different aspects. We can do this in terms of whether the system fulfills our communicative goal of the task, whether the output remains faithful to the input information. We can measure the grammaticality, fluency, or naturalness of the generated text. Or we can define some task-specific measures like how simple is the output of a simplification system? How compact is the output of a summarization system? How cohesive are the outputs from a dialogue system? Or we can take a step back and look at the system as a whole as to how robust it is to shifts in data distributions or how diverse the outputs are in repeated interactions. To make this even more complicated, one progress on one goal might even lead to degradation on a different goal. So we need to actually measure a lot of different things all at once. All of this leads me to my first intermediate conclusion, which is that there simply is no one-size-fits-all evaluation. And if you came here with the goal to have me tell you what to do, I unfortunately can't answer that. What we can, however, is we characterize the different types of evaluations that we can run. And these are typically automatic evaluations, human evaluations, and a more recent development, which are evaluation suites, which I'm going to explain a little bit more in depth later, which are more focusing on the data itself rather than the evaluation metric. So to explain what types of automatic metrics we can define and what the design space for automatic metrics looks like, let's take a look at a very simplified NLG system. Here, we might have one example from our test corpus that we want to evaluate on. And we have an input and associated references, one or more. And we have our model, which I'm going to represent as a black box since we don't really care about model internals for this. And we have the generated text that the model produces for this particular input. Now, the most traditional metrics that we can come up with and that people have been using for a long time, basically since the beginning of this corpus-based NLP, where we're using machine learning to generate text, is that we simply compare the references to the generated text. The assumption that we're making here is that a higher similarity score between the human written references and the generated text means that the system is better or more human-like. As I was mentioning, this is a very traditional approach and it's been around for a long time. And the way that people have traditionally been doing this is using lexical similarity between the two, using metrics like rouge or blue, where we simply compare which words from generated text also appear in the references, or the other way around, which words from the references appear in our generated text. More recently, with the advent of large pre-trained language models, we can also use contextual representations where we represent both the generated text and the reference as a high-dimensional vector that we can then take the similarity of, which we hope will then go away a little bit from the particular word choices and focus more on the meaning similarity between the two. Another approach we can take is that we assume that the input itself already has all the necessary information, and we don't actually need the references. And as long as we have some corpus that we can train a model on to predict quality, we can then use that second model as a metric. This has become especially popular in machine translation, where we want to translate from one language to another. But even in natural language generation, we've seen an increase in popularity of metrics that are based on NLI models. So NLI, or natural language inference, simply measures whether one sentence is entailed by another. And if we run this, we can then measure whether our output is entailed by the input, which can maybe tell us a little bit more about the content rather than just the form. Yet another more recently popular approach is that we can derive secondary information from our input. Here, again, we're making an assumption, which is that the output needs to answer the same questions as the input and or the references, but the actual phrasing as to how the content is phrased doesn't actually matter, since we only care about the output being correct and complete. So we could generate questions from the input and references and generate candidate answers from the generated text and simply look whether the candidate answers are the correct answers to the questions. Yet two other evaluation approaches we can take, still under the automatic evaluation umbrella, is we can look at the model itself, the number of parameters, the latency we get when we try to run inference. And here, again, that might matter more for someone in industry who wants to serve the model to many, many people, rather than academics who might care more about producing the best possible model. On the other hand, we can also look at the generated text and look at what happens across an entire test set, whether the outputs are actually diverse. And the diversity of generated text then gives us clues about how natural and interesting the outputs are, since I don't really care about interacting with the same formulaic, templatic language multiple times. All right, moving over to human evaluation. The way that it works is usually we show some information out of all of the different types of information we can generate to people and ask the people some kind of question. The people here might refer to expert linguists, they might be untrained crowd raters, or they might be authors themselves. And the question space here is basically equivalent to what we want to measure in terms of quality of our system. We could ask whether the output is grammatically correct. We could ask whether the information is fully attributable to the input, and many, many more. That's why human evaluation is usually treated as this gold standard where you can look at a smaller sample size, but you get very high quality answers, whereas automatic metrics are typically treated as something that you can run at scale. Now, coming back to the evaluation suites, there are two types that I want to briefly talk about. One is called subpopulations, where the assumption is that some types of examples may lead to worse outputs. That obviously has huge fairness implications or trustworthiness implications. For example, you can imagine evaluating the summarization system on news articles that talk about female, male, or non-binary individuals and look at the different scores. If the model performs worse on one of the three, that is an issue that we need to work on. So this can be measured through subpopulations by identifying which attributes are associated with which input. They don't necessarily have to pertain to people. They can also be the length of the input or some other non-personal properties. Another type of evaluation suites are challenge sets, where instead of running on the original input, we can run on some other new input where we introduce spelling mistakes, distractors, or any other properties that we want to measure, where our assumption again is that these particular properties allow for a much more fine-grained investigation. because now we know how the model behaves both in the original setting and by introducing spelling mistakes. Okay, I'm sure I've now probably confused everyone by a load of different design spaces that we can go into. But all of this is really to come to the conclusion that not only is there no one-size-fits-all evaluation, the possibilities are essentially limitless. We can evaluate basically anything in any way. And that is also why we're seeing something like this in practice. If we're looking at published papers, often what we're seeing is this move towards standardization, where we hold all the parameters of our evaluation pipeline static, and to be able to compare to previous work, we want to evaluate on the same training and test data with the same metrics, with the same or similar human evaluation. And therefore, the evaluation becomes a little bit of a black box. And all of the choices and reasoning that went into designing this evaluation process is maybe a little bit more opaque, and we don't really know why we're doing this, but we have to because it's what people do. And this is exactly why we have many pitfalls in NLG evaluations that are very, very commonplace. All right. Are there any questions so far before I start talking about all of the different fun pitfalls that you can fall into?
So, hi all. If you have any questions, feel free to leave them in the chat, and I'll read them out to Sebastian either during his talk or in the end. So far, Sebastian, there are no questions, so I guess you can continue and hopefully the next break.
Okay, so now coming to the deeper dive section of the talk, what I just motivated is that there is actually this move towards standardization of evaluation pipelines. But what there also is this move toward very easy to understand outputs of evaluation pipelines. Specifically, focus on the question, is this the currently best approach to address the particular problem? Ignoring all of the others. This you can see in the many, many leaderboards we have nowadays for NLP tasks. This is not unique to NLG in particular, but it might be an issue for NLG in particular because of our large design space for evaluations. Moreover, we have just seen that there is no one such measure that is called quality. There are many different aspects of this. And yet, in a recent survey that I conducted, almost half of NLG papers published at the largest NLP conferences in 2021 make claims about the system's overall quality, which is impossible. So clearly there is something categorically wrong across the entire field that we need to investigate. And I want to give you one example of such confusion of quality in a particular task with what is actually being measured. And to do so, I'm going to look again at text summarization. That is the task that I introduced in the beginning, where we want to summarize a news article. In particular, here we have a very popular de facto benchmark that people run the same evaluation on over and over again over a long period of time. As you can see here on the slide, we showed the screenshot from Papers with Code. And this particular benchmark is measuring Rouge L, which is one particular form of the Rouge metric, on the CNN Daily Mail corpus. In the survey I just mentioned, we found that 100% of summarization papers we looked at reported Rouge, almost 70% only report Rouge, and together the two most popular summarization datasets, CNN Daily Mail and XSUM, are used by over 40% of papers. So I think it's not controversial to claim that Rouge L on CNN-EM is the de facto summarization benchmark. And you can see over time our scores are getting better. And we just assume that this is equivalent with progress on the summarization problem. Well, now let's take a closer look at the ingredients of this pipeline that only has two ingredients. Well, starting with CNN Daily Mail, the first thing we notice is that CNN Daily Mail is actually an English corpus, which means that we already have to revise our statement. We're not measuring progress on summarization, we're measuring progress on English summarization. The second thing we notice is that it's actually not a summarization corpus. The references of CNN Daily Mail are the little bullet points you see on the homepage of the respective news publishers. And they are supposed to be clickbait to get you to click on the article. They're not the summary of the article. They're not complete or cover the entire article. There's no reason why they can't just add additional facts that are not present in the article. And if you ask drought raters whether they prefer as a summary the reference or the first 3 sentences of the article, raters actually prefer the first 3 sentences of the article. That means that if you want to actually make progress on summarization, you just pick the first 3 sentences of the article and you're done. So CNN Daily Mail is already not a great corpus. Now let's look at the second part, which is the metric Rouge L. And we know actually that Rouge L is not the best possible Rouge configuration. It's not the best metric, but it's not even the best configuration for that particular metric that was chosen. Taking a step back, the reason why we're using Rouge L to measure summarization performance was actually because the first paper that introduced summarization as a task for neural models back in 2015 chose Rouge L as a metric because over 10 years earlier than that, in 2004, there was a shared task on news headline generation, and that task used Rouge 1, Rouge 2, and Rouge L. And they just copied that without looking at all the research that came out in the meantime that showed that there are better configurations. And because everyone else just adopted this, because this is now what you need to compare to, we're still comparing on Rouge L, even though there are better configurations out there. There are 2 more issues with Rouge L and Rouge in general. It has a low correlation with different quality aspects like faithfulness. I'm going to get more into that on the next slides. And since it is reference-based evaluations have another issue, specifically that they are confounded by the style and the errors that the references themselves make. So if the reference uses a particular style and your system produces text in a different style, you actually get a worse score. In particular, for CNNDM, the issue is that it's very extractive. A lot of the words or phrases are copied from the original article, so a system that generates more and is more creative actually gets penalized by using a reference-based metric. Taking all this together, that means that using CNNDM and Rouge L, it actually means that we are measuring how closely a model can match the lexical choices of the references in that corpus, which is also only English. But it is by far not a proxy for how well a system performs the summarization task. And that is a very, very common misconception that is being made by a lot of published work. A system that is better at CNNDM is not necessarily better at summarization. Diving a little bit deeper into issues with metrics, we can see more examples as to why they assess form and not content. Take this example here from the biography generation task again, that I introduced in the beginning. Here we have a reference. Michael Dahlquist was a drummer in the Seattle band Silkworm. And we have 3 candidates. One that uses the same phrasing, was a drummer in their X band Y. One that is way too short, but uses the exact same phrasing. And one that is objectively the best, the third one here, was a drummer from Seattle, Washington, but that also adds the additional information, Seattle, Washington, rather than Seattle. And you can see that in terms of both Blue and Rouge, our traditional lexical metrics, the first 2 candidates are better, respectively, than the third. That means that they really look at how things are phrased rather than what is being said, which is a huge issue. In particular, when we look at different aspects of quality, taking, for example, this study here, again on CNN Daily Mail, we can measure the correlation between different metrics and different quality aspects. In this particular study, the authors annotated 100 examples from CNN Daily Mail across many, many different systems, 8 ways, and took the average as the ground truth score that a system should get. And then computed the automatic metric and looked at the correlation of rankings of different systems that they would receive. And you can see here that the rankings are incredibly low correlated with the human judgments across coherence, consistency, fluency, and relevance of a summary. Not only that, a metric that is best might not be the best in a different aspect. And not even the lexical metrics are bad. Even the more modern BERT score, which is based on BERT, so contextual word representations, gets very bad correlations. Going even further, we already see that a single metric might not be enough to measure all the different quality aspects, but there might even be very complex relationships between them. So there were multiple studies that showed that there is not only a lack of correlation between linguistic and content quality, there's also a complex relationship where content quality can only be rated highly by crowd raters if the linguistic quality is already high. So how do you even represent that using automatic metrics? Going even further, I already mentioned that we rely on the references in reference-based evaluations. And unfortunately, most standard datasets, not just CNN Daily Mail, are deeply, deeply flawed in that regard. Wikibio, which is the largest biography generation dataset, for example, the references only cover less than half of the attributes in the input. And the faithfulness level on a scale from 1 to 5, where 1 is like completely made up and not grounded in any of the attributes, where 5 is completely faithful to all of the attributes, the average is about a 2.5, with most people leaning negative or neutral. The only thing that is good about references is that they're typically fluent because they're taken from, in this case, real Wikipedia. And we are then still using these flawed references to compute scores on different models and compare them. But if we actually look at what happens when we fix things, as we did in this study here, here we created an alternative test corpus, which we called SynthBio because it was fully synthetic. We ensured that the coverage and the faithfulness were much, much, much higher than the original data set. And suddenly our scores, according to Rouge and also other metrics, dropped by half. So really, the unfaithful references are not only conflating our results, they're also leading to very inflated performance numbers, which we then see in terms of like how human performance is reached in different tasks. And the models are actually much, much worse. So this part here, talking about the automatic metrics, I want you to take away 2 lessons. The first one is that we should be mindful of what our metrics are and what they are not measuring. They're measuring mostly similarity between 2 things. They're not measuring any quality aspects particular. The second lesson is that issues in the data will often hide issues in the model. And if we have both issues in the model and the data, we don't know which one is actually causing more trouble. So, as I was mentioning earlier, human evaluation is often seen as this savior that can solve these issues. Well, there's also a lot of confusion here. Take, for example, this survey that came out in end of 2020, which looked at almost 500 papers and found that there were 71 different quality aspects, which is good because, as I was mentioning, it's very individual. Different aspects need to be measured. But the details of what is being measured are often not provided. Over 50% of papers were missing definitions, 2/3 were missing prompts and questions that were being asked, 20% were even missing the criteria names of what was being asked of crowd raters. So that means that a lot of papers would group all of these evaluations together under quality in the absence of any better notion. Not only that, also who is measuring can have huge impact on the resulting outcome. I want to briefly mention 2 studies here. The first one tried to attribute variance and ratings to either topics of a summary or the judges, the people who actually made the ratings. You can see that if you run on Mechanical Turk, Amazon's non-expert crowdworking platform, most of the variance can be attributed to the judges themselves, whereas attack, which is the shared task that used linguists or experts as annotators, most of the variance here comes from the topics themselves. So that means that agreement between ratings by linguists and those from non-expert crowdworkers can be extremely low, and crowdworkers often cannot distinguish between nuanced aspects of content quality. A more recent example can be found in machine translation, where there is this yearly shared task on metrics and machine translation. And here, there was this recent switch from non-expert raters to this MQM system, the multidimensional quality metric system that used expert crowd raters to produce very, very high quality annotations. In investigating this switch, the authors found that the agreement between all of the previous annotations that were collected and the MQM very high quality ratings was extremely low, and sometimes between 0.3, 0.2, which means that they were extremely useless at telling us how good a system was actually doing. There is, however, one light in the horizon which completely flips everything that we know about metrics. If we train our metrics on the noisy crowd rater ratings, then the metrics that are trained on this noisy data agree more with the high quality annotations than their training data. What that means is that metrics may actually be more trustworthy than our non-expert annotators, flipping the notion that human eval is this gold standard. Another issue that we often see in these evaluations is that we need many more annotations than are actually being collected. The median number of human annotations is 100 for NLG. And I actually have a hard time finding any paper that evaluates on more than 100 examples. Yet, there is a study that came out last year that showed that to detect a difference of 1 point on a 1 through 100 perfect annotator judgments, and crowdworkers are by no means perfect. And that is particularly an issue as our systems get better and the differences between systems get harder to detect. In summarization, it's not quite as bad. We don't need 10,000 perfect judgments, but we still need 500 to 1,000 to be better than automatic metrics, which we are often not, which means that most of the human evaluations you read about in academic papers, you shouldn't actually trust. That's really really sad, because it really changes the notion of that we have of human evaluations. So taking the lessons here, human evaluations are often less reliable than metrics, and issues with human eval are hidden in the details that are often not provided. I want to quickly also skip through some of the issues with data. Similarly to not explaining details of human annotations, we also often don't explain why we're using the datasets we're using. We found in our survey that about only exclude machine translation from the equation. Moreover, as I already discussed, standard datasets have significant noise. Yet, only 38% of papers explicitly state why they chose the datasets they did. They simply say, we evaluate on X. And that is no longer really acceptable. Going into a little bit more of a preachy mode here is we need to move beyond previous work used X as excuse to continue to work on the same flawed English datasets. We need to reason and explain why we are using the datasets we are using, because better alternatives often exist. Continuing on this, NLG researchers have also come up with ways to probe specific model capabilities in evaluation suites. And we need to do the same for generation. And models degrade as time passes. But again, due to the static nature of datasets that we're not expanding, models degrade. specifically for new summarization, if our model is trained on data from 2010 or 2015, it will do less well on data from 2020. We ran a study on this where we collected new test data sets that included keywords that were related to COVID-19 and compared the scores on these to the original scores that the model got. And you can see by the difference between the diagonal and the actual points on this plot on the right that there is this huge performance degradation if we actually want to run summarization models that were trained on various data sets and various languages in real-world settings that include these kinds of keywords. So all of this means that we need to update our data in many different ways, but only 2% of model developers even contribute to data documentation, and 20% of people create any kind of evaluation suite, but only 5% release them, which is a very, very stark minority in the grand scheme of things. Leaving me with two other lessons. Testing on new, especially non-English datasets should be normal and as easy as possible. And datasets and their documentation need version control. So I've shown you a lot of lessons now. And now I want to go about talking to you about how we can implement them in practice, because that is also not easy. Before I do this, are there any questions?
So I cannot see any questions in the chat. I have a few questions which are all related to how can we actually motivate better practices in the evaluation and data collection and using better data, like everything you mentioned, really. So I have multiple questions. Is this what you're going to talk about?
Yeah, I think that might make most sense to ask in the end.
Okay, cool. So I don't know if everyone has found the chat. I understand that most people might not have used Teams before. There is also a reaction where you can raise your hand. So we can do that in the end of the talk as well if you want to ask a question. Cool. So Sebastian, I think you can continue.
All right. Okay. So I think that actually goes is very related to the question you were alluding to, because as I was showing, there are a lot of studies out there that go back 10, 15 years that point out flaws in evaluation practices. But the implementation seems to be the bottleneck somehow, because clearly people don't follow these suggestions. And I think it is fair to say that we can only really hold model developers accountable for bad evaluation practices if following these good practices is actually possible or feasible, if they get anything out of it. So in particular, I think there is one really big issue with this process. That is, there are many, many different components to better evaluations, and a single person cannot necessarily fix all of these in reasonable amount of time, when there's an easier way to publish papers, which is not do this. Specifically, there is this circular dependency, where at the moment we can't identify whether and how our models fail, whether the failure is attributable to the data, model, or the evaluation metrics or human evaluation. What I mean by this is that flaws in data get amplified by models, but they're not being detected by human evaluation or metrics, which lead to us to continue to use this bad data. And it reinforces this notion of standardization, where if you make any choice that is not the perfect choice for evaluation or the standard choice for evaluation, your reviewers, when you submit papers, might actually be confused because they ask you, why are you not using CNNDM? Why are you not using Rouge? So what we really need to do is, as a community, we need to work on getting this infrastructure up and running to break through the circular dependency. But it doesn't really have to be a negative circular dependency. It can actually be an opportunity to create this positive feedback loop where better evaluation practices lead to better evaluation techniques, which in turn leads to better models. What I mean by this is that if we have better data and we have better models as a result of that, and we have better evaluation practices that identify limitations in these models, we can then identify the flaws in the models much easier. We can work on them, we can fix them, we can use automatic metrics to identify flaws in data, we can improve data over time. And basically what we need to do this is we need to call out limitations of our methods much more strongly. We need to point out and fix issues in the data that we're using. We need to use combinations of different metrics and human assessments rather than just focusing on Rouge alone. And we need to release modern evaluation outputs, especially for non-English language, so that people who do evaluation research, just like myself, can actually use this data to get insights into where models fail and develop better metrics. Expanding on these lessons, in a survey I recently published, we actually made a long list of best practices you can follow, and you can use this as a little bit of a checklist to check yourself. Am I actually motivating my data set and my metrics choices? Am I evaluating a non-English language? Am I explaining all of the human evaluation components and so on? I'm not going to go into detail into this. I just wanted to self-advertise a little bit that if you do this, you'll have better evaluations. But I wanted to come back to GEM, the Generation Evaluation and Metrics Benchmark, because the main motivation we had when starting GEM about a year and a half to 2 years ago was that we wanted to help implement best practices, make it as easy as possible, but also we didn't want to become another leaderboard, which is what many of the other benchmarks that are out there are trying to do. Because as you've seen, and as I've discussed, there are many, many, many different evaluation approaches, and there is no one perfect evaluation approaches. There are simply best practices we can follow, and we should make it possible to choose the most appropriate evaluation approach for any project. And that is the evaluation behind the Generation Evaluation and Metrics Benchmark. Specifically, we identified 2 goals. The first one is that the core of evaluation is data. And the way that we can, as a community, improve on our data practices is that we need to have some kind of consistent infrastructure. We need consistent data loaders. We need documentation in the form of data cards. We need ways to update the data and the documentation over time so that if you find something wrong with a data set, you can simply make a little pull request or just update the GitHub where the data is stored or the data documentation so that others don't have to refine the same issue. The whole thing needs to be modular to expand to new data sets over time so that you don't have to be familiar with all of the data sets that are out there just to be able to contribute to the documentation. The second goal is that there needs to be something in it for people to contribute to the data sets. And that, I think, lies in the metrics, because computing automatic metrics should be possible in a consistent and replicable environment across all of the data sets that are included in this benchmark. So that if you want to try out not just Rouge, but also Meteor, Cider, Blue, BirdScore, Blurred, whatever metric you want, all you really need to, should be able to need to do is to run a script. And if you want to compute any of these for a different data set, you should run the same script, just specify a different data set. So this was the goal that we set out to do, is enable rapid experimentation with many metrics and many data sets. And the way we try to position ourselves is to build evaluation infrastructure by following this build, improve, and expand strategy, where people who build models just interact with the infrastructure. And as contributors and participants in GEM, which we're running as a participatory framework where anyone can sign up to participate, we have these 3 axes. On the data front, we're selecting and documenting tasks as the basic building block. We improve these data sets over time by fixing issues, by filtering them, by creating new splits, new challenge sets. And maybe over time, this will inspire the collection of new data sets that address issues that we haven't been able to test. On the automatic metric front, we can develop an extensive metrics library that is compatible with all of these data sets, but we can also improve on this by allowing the metrics library to give you fine-grained breakdowns, for example, for subpopulations. And maybe we can even use this to inspire the creation of new metrics. On the third axis, the human evaluation, what if we had a reproducible framework that was compatible with our different task types, that uses consistent definitions, quality controls, and so on, without everyone who wants to do a human evaluation having to create an interface from scratch, which is another aspect that we're working hard on. And the final part to expand here is, what if we had this reproducible framework and we collected large annotation corpora that at the moment only really exist in machine translation because they've been running these human evaluations for over 10 years. And we use these large corpora to analyze and maybe even develop these new metrics. I don't want to talk too much about the infrastructure, which might become a little bit boring because it's mostly, a demo style infrastructure where we have many different microservices and infrastructure and libraries. But I'd rather talk to you about GemV2, which is what we're currently releasing, and what we support in it and how to use it. On the first part, we have our datasets. We support 35 different datasets at the moment, all within the realms of summarization, data to text generation, paraphrasing, simplification, and dialogue response generation. And these 35 datasets are available among them in 45 plus languages. For many of these, we've already identified issues in the data, and we've created new splits, we've created challenge sets, we created even linearization processes, which are mostly relevant for data to text tasks. Since we have key value attributes here, or sometimes large tables, it is unclear how to represent a table as a string. And every paper seems to be doing something else. So we've been working on standardizing this a little bit to give you one option of how you can represent an example as a string, so that just when you load the data, you don't have to come up with your own linearization process, which can lead to reproducibility issues. All the loaders are available on Hugging Face using their interface. And on the documentation side, we, as part of Gen 1, created a data documentation interface. And as part of GemV2, we expanded it and made it interactive for anyone to use. So if you are collecting an NLG dataset, you should be able to just go to this URL, and it will walk you through a series of over 100 different questions that will help you document potential issues, social impact, licensing terms, and so on for your dataset. Moreover, within this month and probably 1 to 2 weeks, we'll release a rendering tool that will also allow you to take the output from our form and render this in a really nice and accessible HTML that you can put on your website for your dataset. We also documented all of the 35 of the datasets, which actually led to a total word count of over 70,000 words for all of the datasets that we have. So this has been a massive effort that we've been trying to make improve how we know about limitations of datasets. And finally, we've tried to standardize the environment in which you run metrics. That is, we have developed an automatic submission interface where you just upload predictions from your model and you get back all of the scores. As part of that, you're also volunteering your model outputs to a corpus of model outputs that evaluation researchers can use. Again, trying to benefit from each other and getting this positive feedback loop started. You can also run it locally, and it even supports Docker now for each individual metric to avoid dependency issues between them, which has been a huge issue for neural metrics because everyone uses their own framework they're not necessarily compatible with each other. Really, what I want to implore you to use is just use our infrastructure. We've tried to make it as easy as possible for you. For loading the data, all you need to do is import datasets library and say load dataset gem/whatever of the 35 datasets you want, plus the configuration. In this case, it would load our English splits for Wikilingua, which are different from the originally published one because they had some test overlap. And if you want to submit, all you need to do is construct a JSON file similar to this. If you want to evaluate your system, you can run You can install our metrics library and just run the metrics. And we also provided tutorials for everything. So really what we're hoping for you to do with this is to make better choices or more informed choices about data sets. And you get a lot of metrics out of this. So you can choose which metrics might be the best for you to use. And it's easier to use different types of metrics. There's also much ongoing work. We have our upcoming workshop. We are organizing a shared task on multilingual summarization. We will release over 50,000 human annotations soon. We are trying to build better human evaluation infrastructure, interactive result investigations, and perhaps even collect multilingual and multidialectal data at a much larger scale. So if you're interested in any of this, feel free. We're always open to for signups and to join our team. And with that, I just want to quickly show you my vision of how evaluation should look like in the future. And that is like this, where we have evaluation reports, where all of the different documentation aspects, model cards, data cards, metric informations, human evaluation statements, all fit in together, are linked from the actual results. You have multiple data sets to be evaluated on. You have automatic or manual error analyses. And you have these evaluation suites where you can get breakdowns by dialect or by different types of inputs, which will make for a much more informative evaluation of your systems rather than just creating a single table where your model is on top with the highest shown performance. That my final words will be that we don't really know how to evaluate models. I'm sorry that I couldn't answer that question, but we can do a better job at evaluation. We can write better documentation, we can report more metrics, we can frame model results around where they fail rather than where they do better than anyone else. And the GEM infrastructure can help you achieve this. And with that, I'm happy to take any questions.